Hi everybody, my name is Jeremy Jones and I'm a researcher at the Radar Ecology Lab at the University of New England, Armidale. I'm here today to talk about some of our protected cropping research on apple pollination. Over the last 3 years we've been visiting Stanthorpe, Queensland and recording the amount of insect visitation to apple flowers under various types of nets. So to do this research we surveyed 10 different farms with over 21 different blocks. We did this between 2017 and 2019. Over each one of these years, during peak bloom, we visited these blocks and recorded the amount of insect visits to apple flowers and the height of nets, the type of nets, and also the presence of any nets. So just to give you an example of the type of nets that I'm talking about, on the image on the left, we have two different types of nets and another separate orchard. At the top of the image is a pitched net orchard. Now these nets are becoming increasingly common in Stanthorpe. They have very great properties that make them highly valuable to growers. So these nets are able to split under a heavy hail load and release the hail safely into the inter-row space between trees. Whereas in the white net in the center of this image, you have a flat net. Now these nets stretch under a heavy hail load. They have a risk of collapsing on top of the crop, which makes them less ideal than the pitch nets. And down the bottom we have an orchard without any netting at all. So these are becoming much less common now as growers seek to protect themselves from these risks of hailstorms. So in 2019, many of the growers had started opening the pitch nets. You can see this at the top of the image in the dark rows where they've split the net seams to open up the nets to increase insect visitation to flowers. We studied both types of nets and also compared these nets to orchards without covers. Moving on to some of the results. Overall, honeybees were the main visitors to apple flowers, and they represented 94% of all visitors. Surprisingly, I was expecting to see more visits by various types of insects in the open blocks, but instead we found more diversity of insects in the netted blocks. So overall, despite being dominated by honeybees, there was a good mix of wild insects, including wasps, beetles, and flies. Now, for the wasps and the beetles, we don't really know how well they are at pollinating crops, but these insects actually provide a really good service to farmers in that they control pests like beetles and aphids. So, moving on to the effects of the netting. When we compared orchards with and without netting, as you can see in the image on the left, what we found was that in orchards that were open to the air, represented by the blue box plot, we got a lot more visits. Whereas in the orchard blocks with netting, insect activity was massively reduced. In the blocks without netting, despite having a high diversity of insects, they had a lot more visits by bees. In the red box plot on the left, we have the orchard with the overhead netting, and this had a lot of visits that were only represented by 1 or 2 insects visiting flowers per minute. This also had a really wide spread of observations from 1 to about 10 visits per minute. And the following slides will give you a bit more idea of what actually is driving this difference in these netted orchards. So one of our questions in 2019 was to find out what the effect of net height was on insect visitation. To do this, we measured the height of nets, but when we're in the field, we also realized that actually a much more biological, meaningful way of recording this would be to measure the clearance gap between the tops of trees and the height of the net. So for all the flat nets and pitched nets that we used in our surveys, we recorded these details and we correlated that to the amount of insect visitors that we observed. So the image on the left is a representative of an orchard with a really large overhead clearance gap. So this orchard is probably about 5 meters high, with apple trees at about 2 meters high, and it has a very clear view across the entire orchard block. What we found in these orchard blocks with large overhead clearance space was that insect visitors were much more abundant. So they greatly preferred these net types with this large overhead clearance space. And as the heights of the trees got closer towards the height of the net, this activity was massively reduced. So this is a really great way to optimize insect visitation in apple orchards, simply by pruning the apple trees to a lower height or instead putting up nets that are much higher. Looking at different types of management strategies to increase visitation to apple flowers, we also looked at the effect of opening overhead rows on insect visitation. So the image on the left top has an orchard which has had every single row opened. So this gives an effect of a really bright and luminous orchard, and there's a big gap for insects to move in and out of the netting. In the process of recording this data, we walked across perpendicular to these overhead rows, and we recorded all the insect visitors to each apple tree and whether or not the overhead net had been open or closed. So what we found was there was significantly more insect visits under those rows that had overhead nets that were open as opposed to closed. Now, we're not really sure what the effect is overall, but we suspect that this increased visitation under the rows that had been open will also lead to greater visitation across the entire block. In summary, just to wrap up these findings, what we did find was that orchard nets really reduced visitation by insects. And we found that having a really good clearance space above trees, that is, having trees that are pruned low or having nets that are really high, or some combination of those two things, led to a lot more insect visitation. And also, for pitch net systems, opening up the overhead rows really increased insect visitation. In the future, we hope to find out what this actually means for apple quality. As many of you will know, a good pollinated apple flower leads to a really high quality fruit that's nice and symmetrical. So we're going to find out what that effect is on these apple fruit, and also how this might vary by different cultivar. So for instance, the pink lady that we studied is highly self-compatible, which means that it doesn't actually require very many pollinizers to get a good crop. Whereas a variety like Gala actually needs a good amount of pollen to be transferred from a different variety in order to get a good fruit set and a good quality apple. So I'd just like to thank a few people. First off, I'd like to thank Stephen Tancred from Orchard Services in Stanthorpe, and the growers that participated and warmly welcomed us onto their farms to do this research, and also other members of the lab. And also I'd like to acknowledge the assistance from Hort Innovation and the Australian Government Department of Agriculture and Water Resources.